Good afternoon, everyone. My name is Brian McCauley, and this is Emmanuel. And we are Team ATP. Our project is a portable solar power system. Like I said, Brian and Emmanuel are co-team leaders on the project. A little bit about our background with this project. Our client, his name is Corey Wenger. He works for a missions organization that supplies portable solar powered units to missionaries in these countries here in Indonesia, Cameroon, Africa, and Papua New Guinea. They currently are supplying these systems to the missions there, or the missionaries working there to power a laptop and a printer out in the missions field. Here's our problem statement. Just the main points here that we picked out. Our project needs to be easy to carry, easy to set up, and reliable and efficient for the missionary using the system. The system also needs to be able to operate between 15 and up to 100, or excuse me, up to 50 degrees Celsius, because it will be primarily used in the Pacific region of the world. The system also needs to be splash-proof, just in case it comes into contact with any liquids, as well as be secure enough so that insects cannot nest inside the components. Okay, so just the needs real quick. It needs to be portable, splash-proof, efficient, operate between 15 to 50 degrees, and also keep bugs. From our problem statement, we broke down and created an objective tree, and then we took the portability, all these features that we wanted to include with our product, and added more specifics to those. You can see there. And then from that, we also created a function means tree to the specific functions that our product will carry out. We wanted to maximize the solar collection and efficiency of the entire unit itself. And we're going to be using a DC supply versus AC, because with the AC you have to use an inverter, and that just does not help out with the efficiency, overall efficiency. From there, we took our engineering requirements and then gave our justification for those. Standard electrical wiring codes, just saved by the laboratories, safety. Okay, this next can't connect inside, and it must be water. And it can't be able to catch fire in case there's a short circuit. Our work breakdown structure for our project here is a list of the tests that we're going to need to complete, the people who are assigned to take on those tasks, and how long each test should take. And then from that, we also created a Gantt chart. And here's our Gantt chart, which also basically gives us the same information in the work breakdown structure, with more of a timeline, as we all know. And then,
I go on the part of the concept of our design. So after having developed the work breakdown structure, having the objectives true, and know our Gantt chart, then we had the general concept of our design, the design compared to the work we've done. Not committed, but we've done the design. So the general idea is that there is solar energy that powers solar panels. Then solar panels transform the photons into electricity. That electricity is not stable, so to stabilize it and be able to charge the battery with it. We need a charger controller, so we use a charger controller here. Charger controller to charge the battery. And we may need an inverter, but we don't have to, because we are not using it, because if we use it, it's not as much efficient as in case if we go this way with the DC current. So we are going to use this way, we are not going to go this way because of the circumstances where they are going to be using the electricity overseas. So So they will be able to use it efficiently with the DC load. Then here are the materials we are going to use. Not we are going to use, just the materials that are necessary for different concepts. These are here for like, these are suitable for our concept, like the idea we have with the design. If we use these solar panels, they are affordable, they are light, and they provide as much as electricity as the solar panels, except that they are supportable and they are not that much heavy. This one is too big, so we don't need like something that is too big that is going to be too much load for the client. And then this is brush proof and it's malleable, but these materials they cannot be easily folded and they may break. So we can choose to use such a thing. So here is this one here, which is it looks really too heavy, so we didn't choose it either. Then this is the case of this. So we didn't choose this. These are the different materials, but among them, this was the most suitable. Then afterwards, we did a functional design. Now, functional design will be using two solar panels of 60 watts each, and they were 60 watts each, and they will make the 124 watts total of power. And then the charger control will be here, the battery, the power plant, where the loads will be used, take the electricity from here. And then different materials that would be needed, is it the fuse, the ground rod here, like lightning protector, the power storage. These are the wires that goes to the power storage, which is the battery. And then these are the wires that will go to the solar panels, and others will go to the power plants. This is actually the design of our project. Then the next thing is the material quality specification in order to meet the requirements. So the quality of the materials we have chosen to use to implement that design. There must be a small size so that all of them will fit. At least we will have this dimension in inches of 21 over 14 over 8 in inches, and then the battery. The battery will be on itself. We can put together the solar panels, charging controller, and the other accessories. Then there must be a light so that we choose the materials that are lighter than others so that the client will be able to carry that. Then it must be easy to manipulate, which means easy to use, or if you want to set it up, it must be easy to set up. Then it must resist high temperatures, about 45 degrees Celsius as the client wants it. Then it must be waterproof, splash proof, so not use it permeable. It must be efficient, so we have to choose like the charger controllers that has high efficiency than other charge controllers, and choose the battery that it can take as much as electric charge as possible without losing too much heat, without losing electricity through heat, too much electricity through heat. And then it must be reliable. The client needs to use it, and if we use it, it must not break that easy, or if the client uses it, it must easily fix it, not too much trouble. Then here are the materials we choose. This is the charger controller. We found it on Amazon. It supports up to 30 milliamperes. And then this is the ground rod. We are going to use the SA2 pin connectors. They are the size of 8 AWD. It's an American unit of measuring the wires. But this is necessary to be able to use it with the charger controller and the solar panel. We chose this because that's what the solar panel, like specification of the solar panels, we're gonna suggest to the client to buy. That's what it says. Then we have a power outlet. The power outlet is the current port, and we use a laptop adapter that can be plugged into the power port. That is also doesn't change from AC to DC. It's just an adapter from DC to DC. It's through which the laptop can be charged. So this adapter helps a lot in not losing too much electricity because we don't have it to use the internet. So that's the good thing about it. And then the battery. This is the battery we are going to use. We're going to order it online as well. It's already ordered, I think. And then this is the casing we chose. This customer made casing. It's waterproof. It is easy to carry with all the materials. They can fit. Then here's the budget of the materials you're gonna use. The solar panel, the screw in here cannot afford it, so it's not included. That's why I did include it here in the red. And here are the materials: charge controller, battery, wires, the ground rod, fuse, outlet. And the prices here, and all of them, the total is gonna be about 300 and something. Yeah, because the prices change. This is the estimate for today. Yesterday it was not the same, but it's about 330, 50 or 70. It's not more than 400. It's not less than 300. That's the kind of range we usually see. Then here's the prototyping. Brian can explain a little bit about it.
Since we have just ordered our materials for our project, we obviously haven't started our prototyping yet. So as soon as the materials come in, we will hopefully get started on working on the prototype as soon as possible. Is there any questions?
What testing do you plan on doing once the prototype is construction?
Plan on testing. Well, hopefully, if our client sends us the solar panels, we will use the solar panels, build our prototype, and then run a test on that, connecting a laptop up and test for efficiency and just overall efficiency of the product. And then if we don't end up getting the solar panels sent by the client, we're going to have to come up with a way of implementing a solar panel that we don't have.
Yeah.
So.
We have the calculations we have done for how long it is going to take to use the solar panel. So we have those calculations. We found that it may take the client wants it to use it and be able to use the laptop with it for about 8 hours. So on our calculations, with the battery full, we found out that it can be done up to 10 hours. So we're going to test it and see if it can miss those calculations as well. Any more questions? Thank you.